A, an 8085 microprocessor uses all available jump instructions, each only once. For this program, the total memory in bytes occupied by the conditional jump instruction is. In case of 8085 microprocessor, the total number of jump instructions are 9, that is including jump. Jump, here is address. Here jump on no carry, jump on carry, jump on positive, jump on negative, jump on parity even, jump on parity odd, jump on 0, jump on non-zero. So if we consider only the space occupied by the conditional jump instructions, those are 8 conditional jump instructions are available. Each conditional jump instruction occupies 3 bytes of memory. Hence total memory space occupied by the conditional jump instructions is 8 into 3, which is equals to 24 bytes. Hence option C is correct. Question is, a communication system operates in an AWGN channel and employs BPSK modulation. If EB by N naught equals to 4, that is EB is signal energy per bit, N naught is noise PST, and given that error function of 2 equals to 0.936, the average bit error rate is. See, for BPSK modulation, the average bit error rate is 1 by 2 error function of EB by N naught under root, which is equals to of 2, which is 1 by 2 into 0.936, which is equals to 0.468, nothing but 4.68 into 10 power minus 1. Is which one of the following cannot be the autocorrelation function of a real WSS random process? If we consider ABCD statement, the statements here, Rx of tau is an even function, as well as tau tends to infinity, it's going to be 0. Whereas in C2, tau tends to infinity, it is also going to be 0. In DS2 is also going to be 0, but except B. Hence option B is correct.
When reading 0.1 volt on 10 volt range, okay, we have plus or minus 0.5 reading. Okay, plus or minus 0.5 reading is equal to 0.005. For 0.1 voltage, it is into 0.1. So this is 0.005 volts. Similarly, for plus or minus 1 digit, what does it mean? That 0.01. What is the total value? 0.0105. Okay, this is what reading on 0.1 volt on 10 volt range. Now what is total possible error we have? Total possible error is 0.0105 instead of 0.1, okay, into 100. So this is 10.5 percentage. Option C. We know form factor for full wave rectifier. Okay, form factor for full wave rectifier is equal to 1.11. Now what is this one? This is Vrms by V average value. Now from this, what is V average? Vrms by 1.11. In question he has given RMS value as 2.22 volts. Since rectifier indicating 2.22 volts, this is 1.11 volts, okay, which is equal to average voltage is 2. Okay, now we have triangular wave shape as an input. Okay, now if you have triangular wave as an input, peak value is given as 2 times of average value. Okay, 2 times of average value is 4 volts. Now RMS voltage as Vrms is equal to Vm by root 3 for triangular wave. Okay, We know Vm as 4. This is 4 by root 3, which is equal to 2.31 volts. Now, what is percentage error here? Percentage error is equal to percentage error is equal to 2.22. This is measured value. True value is 2.31. Okay, minus 2.31 by 2.31 into 100. This is minus 3.9%. Option A is correct.
Accidents occurring in a city in a day by Poisson variate with mean 0.8. Find the probability that on a randomly selected day there are accidents. So it is given that lambda, which is mean of the Poisson variate, as 0.8, and we have to find the probability that on a selected day there will be accidents. That means there must be at least one accident. So in order to find probability of at least one, it is enough to find 1 minus probability of no accidents. Now, we know the formula for Poisson variate. P of x is equals to k, which is equals to e power minus lambda into lambda power k by k factorial, and lambda is given as 0.8. Now we need p of at least one accident, which is nothing but 1 minus p of no accidents. For this no accidents, value of k will be 0. Just substitute the values. E power minus lambda, that is 0.8, into lambda 0.8 power k 0 by 0 factorial, which is nothing but e power minus 0.8, 1 minus 1 minus, which is equals to 1 minus. If we simplify this value, it will be 0.449, which is equals to 0.551. Hence the required answer is option A.
In this question, we have to find deflecting sensitivity, which is S is equal to L into LD by 2D EA. It is given as L into LD by 2D EA in CRT, which is equal to 3.3 into 10 power minus 2. Length of deflecting plates is 4.5 into 10 power minus 2 by 2 into 10 power minus 2 into EA is 300 volts. Okay, which is equal to 0.2475 mm per volts. Option is D.